Try to define the word bark for me. If I show you a picture of a dog, you hear a sound. If I show you a tree, you feel rough wood. The Pictionary definition means almost nothing until you know the surroundings. For decades, early computers couldn't do this. They processed text rigidly, reading one word at a time, straight out of the dictionary. This image shows exactly what happens when a computer ignores context. If you translate a German sentence into English strictly word by word, you end up with a confusing, jumbled mess because the phrasing completely falls apart. To actually understand language, AI had to stop treating words as isolated islands and learn how to read the room. Let's look at a short sentence. Life is short. Eat dessert first. Think of these 6 words as guests arriving at a cocktail party inside the AI. When they walk through the door, the computer checks them in by assigning each word an ID number, much like handing out a blank name tag. This diagram shows input embeddings. The computer converts each ID number into mathematical coordinates, placing each word in a 3-dimensional room. But notice they are completely isolated, with zero awareness of who else is at the party. These coordinates explain what the word means in a vacuum, but they tell us absolutely nothing about how the words relate to one another. That brings us to self-attention. This is the mingling phase of our party. Every single word looks across the room at every other word to figure out who it should be talking to. Here we track the word dessert. Evaluating its connection to life, it registers a very low score. But when dessert looks at eat and first, there is a massive spike in relevance. Because of these strong connections, dessert moves closer, absorbing context from its neighbors. Through self-attention, a word sheds its rigid, static definition. It becomes a fluid, mathematically rich concept shaped entirely by the company it keeps. Think about how systems like ChatGPT write. They don't output paragraphs all at once. They predict and generate text one single word at a time. This introduces a strict rule called causal attention. Back at our party, it means a guest is only allowed to mingle with people who have already walked through the door. This grid illustrates how the model enforces that rule with a mathematical mask. You can see everything above the diagonal line is blocked out entirely. The system hides the unwritten future words, so the AI cannot cheat and look ahead. By blocking the future, the model has to make its best guess for what comes next based purely on the exact context of the words that have already been established. Advanced models take this process and multiply it. They host dozens of these microscopic cocktail parties all at the exact same time. Engineers call this multi-head attention. Each separate party, or head, is looking for a distinct type of connection. One might focus purely on the grammatical structure, while another scans for the emotional tone. This schematic shows the full transformer architecture. This is the framework running under the hood of large language models like GPT and Llama. If you look closely where the blue arrows are pointing, you can spot the exact blocks where this multi-layered context gathering happens. When an AI gives you a highly nuanced, intelligent-sounding answer, there is no conscious thought behind it. The system is simply running millions of these attention calculations, ensuring every single word perfectly understands the vibe of its surroundings.